Okay, the next up in this category of 10 tons to 100 tons is a house. This makes sense to worry about. 80 tons of CO2 equivalent, that's equivalent to 5 brand new family cars, 8 years of a 10-ton living, or 24 economy class trips to Los Angeles and Barcelona, between LA to Barcelona. Wow. That's pretty big, so you better think carefully when you invest in a house. But there is good news. Here is embodied emissions in buildings, in building a carbon neutral 2-bedroom bungalow. Photovoltaic panels struggle to justify themselves financially. So the embodied emissions are 60% in the walls, pipework and drainage. Photovoltaic panels are a tiny bit of it. Floor beds, slate roof, and timber. Okay, so this should tell us a little bit about where one could reduce the carbon footprint, right? But this is a carbon neutral 2-bedroom bungalow. So the embodied energy and carbon footprint is basically done this way, where you have materials, there is a design, production, transport, and use, and then there is disposal and hopefully recycling back to materials. This comes with embodied energy and carbon footprints for anything you buy, a house, car. Here it's a vehicle that's being the product here is being shown. We don't say what it is, but we are using it, so it could be anything. Usually you would want to worry about things like this. Do some sort of an eco audit where you assess energy per CO2 over its lifetime. So materials, mass of the part, embodied energy, CO2 per kilogram, virgin content, manufacture, transport, use, disposal, worry about toxic materials, materials that cannot be recycled. You have to minimize mass, thermal loss, and electrical loss, and so on and so forth, depending on what you are worrying about. So I'll show 2 examples of how companies are now selling themselves as architects who can build you energy efficient, environmental friendly, carbon neutral homes, and how they do it. So they means that there is a way to make money by being environmentally friendly, and this always appeals to people because you are seen as part of the solution rather than a problem. So here is kilograms of CO2 created or stored to create each ton of building material. This is from c2.co.uk. I'll show how they build their houses. So wood is already captured the carbon from the atmosphere, so it has a negative footprint. Steel has a fairly high footprint. Brick and concrete, we already talked about cement and concrete, so how it is used is very critical. For example, a house made of timber versus an apartment complex, high-rise made from cement or concrete, can be very different. And now there are also ideas of building high-rises with wood. I have a podcast on that in my course on drawdown, or bending the curve, where you can see how it is possible to build safe, long-lasting high-rises with woods. Generally people don't believe it's possible, but actually it is possible. Okay, so distribution of embodied CO2 in kilogram CO2, foundations, drainage and floors. So average refurbishment versus average new build. So this gives you a sense that it's better to refurbish a house than to knock it down and build. In many places, like let's say La Jolla, California, on the beach, rich people come in, the cost is all for the land. They buy the existing house for a lot of money and they knock it down and rebuild it. Why? Because they want their own particular design and so on. Brickworks, so new build is much higher than refurbishing. Carpentry, windows, doors and roof, plasterboard and plastering, electrics, plumbing and heating, decorating and sundries. Okay, so annual heating needs, this is of particular relevance for houses in the UK, US and other parts of Europe and Russia and wherever it gets cold enough. So C2 Plot, which is the company that builds you this eco-friendly house, versus a typical 4-bedroom detached house or a typical 3-bedroom semi-attached house. So often you have these row houses which are attached, so they consume less heating energy per year than a detached independent house. Okay, and the C2 plot will reduce it significantly according to their design. How do they do it? So they focus on zero carbon design. The C2 homes uses timber framed design, so each house stores 23 tons of carbon and prevents the emissions of 88 tons of CO2 compared to building an equivalent masonry house. So there is an offset. That's roughly the same as taking 19 cars off the road for 1 year. Timber also has excellent thermal properties, helping to lock heat within the building for far better than brick, concrete or steel ever could. Did you know that? That's good to know, right? They also are green from the roof down. This is from their own website. The vegetation of the green roof serves as a living insulation, keeping the building cooler in summer as well as warmer in winter, saving energy and reducing emissions. Green roof helps to reduce the urban heat island effect, reducing summer temperatures and lowering cooling requirements across the city. The carpet of plants will also filter the air, removing pollutants and improving air quality across the development. Who doesn't like greenery, right? So, fantastic. They also use special insulation materials. They take care of natural lighting. All sorts of things are taken care of. Here is another company from Australia, the Anderson Architecture. Shows the typical breakdown of energy consumed by separate elements of a building across its lifespan. So site work, envelope, structure, finishes, construction and services. What does Anderson want to do? It wants to reduce embodied energy as well. Here is in gigajoules the embodied energy of a typical house in Australia compared to that of imprint house which they build. So it's 295 gigajoules when they do it their way. An average Australian house on the other hand is almost 4 times at 2.5 times at 1000 gigajoules. That's a massive saving. Embodied energy when the grid is off, when the house is off the grid, or it is an average Australian house. Okay, embodied energy of a typical house in Australia compared to that of off-grid house. So 663.43 versus 1000. Again, significant savings. Okay, so there are private companies which are offering you environmentally friendly constructions of homes, saving you not only embodied energy and carbon when you build it, but also lifetime savings on energy consumption and so on. Okay, just to look at a few more related numbers. US household emissions. Transportation and housing account for more than half of all US household emissions, both at home and overseas. So US obviously relies a lot on imported materials. So you can look at housing, transportation, services, food and clothing, and you can see the numbers, what is domestically generated and what is being imported and is generated overseas. This is very important because the embedded carbon in trade is usually not very accounted very easily, but it's good to keep in mind. We saw the example of China, and we'll see another map here of how US household emissions are creating emissions elsewhere based on these categories. Breakdown by category: housing, utility, furnishing, supplies, shelter, miscellaneous goods, electronics and machinery. So utilities take up a lot. Here housing and transportation take up a lot. Food and clothing are up there as well. In transportation, fuels take up a lot. Public transportation, transportation services, vehicle purchases. Food, services, so other services, health, entertainment, and education. You can look at where US exports its household emissions. So whenever we are consuming at home, we are buying things from outside, which is essentially equivalent to exporting the emissions outside. So this is carbon footprint in megatons of carbon dioxide equivalent. So products that use home may contribute to the greenhouse gas emissions of other countries. Majority of US households overseas emissions are produced in China, not surprising, as well as in 24 other countries highlighted here. So India, Russia, lots of Europe, Brazil, Mexico, and Australia and Southeast Asian countries are all exporting things to the US, so that the household emissions there are originally produced here, and the trade is carrying the embedded carbon and energy along with it. So you can see this massive carbon footprint of US household emissions in China. Okay. Obviously, household carbon footprint varies by income level. The more money a household has, the more average tons of carbon dioxide equivalent it emits per year. Tons of CO2 equivalent per household for food, housing, clothing, transportation, and services. You can see less than 5,000 up to 150,000 and more, and it goes from 20 tons of CO2 to almost 100 tons of CO2, and the fraction of the contribution from services increases dramatically, as well as the housing itself increases dramatically, and other consumptions like food and transportation go up as well. Okay, so you can see that clothing changes, but not that much. So you can expect that household income is going to determine your standard of living, and that directly translates to your carbon footprint. So can you be rich and live with a low carbon footprint, have a house that is got low embodied energy and carbon? Of course you can, and these environmentally friendly architecture companies and so on do offer this option, and hopefully more and more rich people begin to opt for these environmentally friendly options to reduce their carbon footprint, which is typically very high when it comes to luxury consumption from luxury goods. Okay, top 1% emits almost the top 90% of the luxury consumption carbon emissions. So all these things are very useful to keep in mind. Okay.